Hey YouTube, what's going on? Daniel Dallas right there. So, NCERT students, I opened a new series dedicated to exercise solutions for NCERT program. And here I'm going to consider chapter 12 dedicated to linear programming problem. So actually, I start development dedicated to linear programming problems, and in previous video and a couple of videos you actually saw the results for that. Okay, hope you like that, hope you actually assessed in a good way. So thank you guys for watching. So what I'm gonna do, actually I'll tell you the plan for the first how I'm going to present materials. So I'm not going to resolve all the problems that actually you have in your NCERT books. What I'm going to do instead, I'm going to provide my variations so that you can practice, you can have a chance to practice. And at the same time, you have a chance to compare solutions with what I have. Actually, in YouTube, there is lack of English explanation for chapters, and especially for linear programming. At least I did a little search for that, and actually I haven't found any proper material explained in English. So my goal here is to provide similar, maybe so with a little variations, but dedicated to the same problems. So as you can see, for example, I just give an explanation for question 1. So here you have to maximize the objective function z, which is equal to 2x plus 4y. So actually what you have in your books, that's 3x plus 4y, okay? So subject to constraints. So constraints that you have in your books is x plus y less or equal than 4, x more equal than 0, and y more equal than 0. So it's pretty similar, so I decided to change a little bit. However, so for next, for the following questions that you have in your books, I'll have variations, and so that you can try your skills, try to apply your knowledge that you've got here, okay? And also it's going to be very useful for you guys because my explanation is completely made in English so that you can practice with terms, with math skills as well. So I hope that series is going to be really helpful for you. So join guys who haven't done that yet. So guys, share this video to everyone who interested in NCERT educations and proper explanation. So I hope it's pretty clear. I hope it's in depth, so I explain not only just what exactly to do, but also I provide some proofs, I provide some explanation why you actually need to do so. And let's go. That was the short intro. All right, so we have question 1. You need to maximize the objective function z, 2x plus 4y, and you have the following constraints set up as set of inequalities. Okay, so try to pause the video, try to do by your own, and let's see explanation. Okay, so right now what we have, so we have that we had set of x's already. I set up for you guys, so I shift a little bit and we start discussing. So we have the objective function z. As you remember, what actually we need to do, first of all, we need to find the region. So the first step, we need to draw up the region. So x more equal than 0 and y more equal to 0, set up the first quadrant, right? Set up the first quadrant so that it's already here. So that's positive x because x more equal than 0, and that's the vertical line that goes there. And for y, you also need to have only positive values, and origin also fits up because you have non-strict inequality. All right, so let's set up the line L1, which is the main line, and for line 1 it has an equation in general form. x plus y equals to 3. So inequality would change to equation because right now we're going to set up the boundaries. All right, so that's definitely y-intercept. So you can rearrange in the way of gradient-intercept form. So 3 is going to be, in this case, 3 is going to be y-intercept. So this is y-intercept, is where the line set up by this equation across the y-axis. So you have 3 here. All right, and it goes with the negative gradient, so obviously it's going to be negative 3. Oops, my fault. Positive 3, of course. So with the negative gradient, so you can check by your round by plugging different values. So for example, if you set up x equals 0, so you'll get 3. So this is an alternative way of using data table, and there you need 2 points. So that's the first point, 0 and 3. It's right there, okay? And the second point, you just plug y equals 0, and you can easily figure out that x is 3. So that's the second point. So you see, you can apply different techniques, either using data table or just having general understanding where y-intercept, which gradient, and now we actually setting up the region. Okay, so I'm going to use green color for the region. So that's the line L1, it's here, and we also limited our region according to those 2 inequalities. All right, so region is there, and what I'm going to do now, so actually, if you like, I can even shade it. So that's our region. Or as you can see, it's bounded. So we go to next step, we judge about, is it like bounded region? Yes, it is. The answer is bounded. So I just remind you, the bounded region is when you can enclose with a circle that region, and in this case, whole region will be within a circle. If you take the radius for 3 of the circle, it will be successful. So all region will be within the circle. And we go to the next one. So the next one, we need to calculate the objective function and the vertices. So we have vertices there, okay? 0, 0, 3, 0, and 0, 3. So we set up z value here, and we set up the table for vertices. All right, so what I'm going to do, I'm going to say that, okay, so that's one setup. So that's the points, let's say here, and that's going to be z value. All right, so how many we have? We have 3 vertices, so we start from 0, 0. Okay, that's x, y coordinates of the vertices, and here is going to be z value when we plug those into objective function. So the equation one more time is 2x plus 4y, so that's why it's going to be 0. So the value for objective function is going to be 0. All right, so let's move next. We plug in 3 and 0, so that vertex 3, 0. After plugging in into the z, we'll get simply 6. All right, at least this value is greater than 0. We're looking for maximum now. Okay, and the last one is 0, 3. So we plug in again, and we understand that 3 by 4 is going to be 12. And that's the greatest value. So because the region is bounded, so it's bounded region, so that means this largest value is going to be maximum. So you can say that this is the largest, and because of bounded, so it's going to be the max value. That was pretty easy, no problem with that. I hope you understand, it was pretty clear. If you have a look at your book and add a solution, so you'll see probably almost the same picture, okay? You have region triangle, but a bit different coefficients. Anyway, that's done. I hope you understand that. If not, just go back and roll back and just come to the very basics where I explain you theoretical basis. So if you're new here, smash the bell button and subscribe, guys. Join, because this course is going to be a crashing course for you. Hope you like that. Share ideas in the comments. Probably state what the topics is really urgent for you, and I can consider that, no problem. And that was Daniel Dallas. See you later.